In this video we are going to discuss about the MOS. So on completion of this topic, students will be able to explain the electrical properties of MOS transistor, explain the DC characteristics of the CMOS inverters. So MOS stands for metal oxide semiconductor. So this metal oxide semiconductor is used for constructing the transistors, and they are mainly used with a variety of modern electronic and power electronic devices like inverters, microprocessors, memory ICs, digital logic circuits also. So what is MOS transistor? It is a type of field effect transistor that can operate in both depletion mode as well as enhancement mode. So this MOS transistor typically consists of three terminals, mainly gate, source and drain. So the major parts of this MOS transistor are semiconductor channel, oxide insulating layer, metal gate and transistors. The most important point to know about the MOS transistor is it is a voltage control device, which means the operation or current flowing through the semiconductor channel is controlled by varying the voltage applied to the gate terminal. So in the MOS transistor, the gate terminal is made up of metal and it is separated from the semiconductor channel by the insulating layer, which is made up of the silicon oxide. So this arrangement allows this gate oxide to establish the electric current in the semiconductor channel and control its electrical conductivity. So you can see the construction of the MOS transistor. MOS transistor consists of lightly doped semiconductor and substrate, two heavily doped regions, oxide layer and metallic gate terminal. So here the basic construction of the MOS transistor is to construct a MOS transistor. A lightly doped semiconductor substrate is taken, into which two heavily doped semiconductor regions are diffused, which acts as a source and drain of the MOS transistor. And this oxide layer is made up of the silicon dioxide, which is deposited on the lightly doped semiconductor substrate, to which this metallic gate terminal is attached. So this oxide layer will be acting as an insulating layer between this metallic gate terminal and the lightly doped semiconductor substrate. And the operation of this semiconductor is here you can see the two types of the transistors, NMOS and PMOS. So in case of NMOS, a lightly doped p-type semiconductor substrate is diffused with a heavily doped n-type region, and insulating layer is deposited on the p-type substrate, to which this metallic gate terminal is connected. In the case of the when we are applying the voltage to the gate terminal, it creates the n channel in between the source and the drain, and the NMOS transistor, the heavily doped n-type regions will be acting as a source and the drain. So this can be occurred beyond the saturation region, and in the case of the NMOS region, the lightly doped n-type semiconductor substrate is diffused between two lightly doped p-type substrates. So this will be in the presence of source and drain, and is deposited on the surface of the n-type substrate. When you are applying the voltage at the gate terminal, this will be producing between the source and the drain, through which the current is flowing into it. So here also we will be finding out the three regions: cutoff region, saturation region and linear region. So here main thing is the MOS transistor can operate as a solid state switch or an amplifier. So the operation of the MOS transistor is completely depending on its type and the biasing. So it can operate in two modes, namely the depletion mode and the enhancement mode. So the MOS transistor will be having the insulating oxide layer between the gate and the terminal, which acts as an insulating layer which increases the input impedance of the MOS transistor. So the main thing is depletion mode and the enhancement mode. Gives questions on MOS transistor. What are the necessary conditions for the different regions of operation of CMOS inverter in MOS transistor? Thank you.